We will now welcome Tanguy of Auffret-Postel to present his research. He's a third-year PhD student at the Theory and Experience Architecture Studio, and he will talk about airtight spacetight, the influence of airtightness on the conceptual approach to space at the end of the 20th century.
Hello, everyone, and thank you very much for the whole team for organizing this very nice event, because as we all know, research can be a bit kind of a lonely practice, so it's always good to get together. So my name is Tanguy of Auffret-Postel. I'm an architect, and I'm currently a second-year student within the Texas lab under the supervision of Professor Eric Lapierre. So first, I'd like to introduce the broad frame of my research. I'm interested in understanding how technical facts become cultural ones once they enter the realm of architecture. So, for example, steel, concrete, but also ducts and even wires have all been studied through the combined lens of history and theory to understand how they have shaped the conceptual apparatus that is used by architects to make projects. In my doctoral research, I am looking to the cultural implication caused by the appearance of a new material regime of energetic scarcity in the 1990s. But for this short presentation, I want to focus on a more specific subject and more of an open question that I'm exploring right now to discuss with you, which is the implication of airtightness on architecture at the end of the past centuries. So first off, just to start off, the idea to insulation and climate control is an old story in architecture. The idea to contain energy within a building to ensure both an appropriate inner climate and to decrease the consumption of energy has been circulating within the architecture field for a long time. So you can see from the Orangerie, but there are of course more ancient examples, but the Orangerie in Versailles, which is an amazing space that has never gone under 5 degrees, just based on solar input and raw inertia from massive stone walls, to the double windows that you can often see in vernacular architecture, Swiss architecture, to the many inventions, industrial inventions of the 20th century to create isolation systems. It has been a long journey towards the energetic performance that we know today. And so, of course, architects, but also historians and theorists have long been looking at the formal potential of technical devices. Here you see the epigraph that Rainer Banham used in his book, The Architecture of the Well-Tempered Environment. It's a traditional song that says, open up that window, let the foul air get away, open up that window, let the foul air out. I don't know how to sing it, I'm sorry. But, maybe for my third year, I'll try to get that right. So of course, the idea to kind of renew air and to let it flow was something that was already very present within the field in the 1960s. And of course, in his book, Banham looked at how technological and mechanical systems had shaped architecture around climate control, and of course, how it would influence architecture in the future. And of course, one building he cited was this Olivati factory by Marco Zanusso, but also the Centre Pompidou, that was maybe the most important building for Banham. But what we discovered is also that even though the technical apparatus of Centre Pompidou was so important and integrated within the building was had very poor thermal performance and very quickly had huge problems because it required huge amounts of energy. So this idea of just looking at how to distribute energy shifted, and to understand that we need a bit of context. So starting in 1973, The report on the limits to growth produced at the MIT by Donella Meadows and her team used the nascent power of computers to model the resources of the planet. This research enabled these scientists to identify planetary limits and to predict their depletion. And of course, the two oil crises of 1973 and 79 also shed a crude light on the energetic dependency of Western countries. And so, of course, the cost, but so more than this ecological new kind of consciousness, the cost of energy was a real driver led by the two oil crises to force politics and therefore industries to address the issue of energetic scarcity and its economical implication. So here you see an advertising that shows that you can just save money by putting in insulation. And this is a Swiss, this was run in the Swiss magazine Architecture.Ingénieur Suisse in 1979. And of course, new technological products appeared in that period. So here you can see a screenshot of a Netflix show or a BBC show running on Netflix, which is a white gold, which tells the story of how PVC plastic windows were sold throughout the UK and generated a lot of money, also with very low ethics, and also an advertising that you can see for this kind of cutted window that you saw also at the beginning of my presentation, that have become kind of the symbol of how normal building systems and blocks have become technical systems. So what we see coming from Banham and the idea of distributing energy is a transformation and the way that we shift from energy distribution to energy preservation. So far from the utopian aesthetics of the high-tech, architects in Germany and researchers, which is a country where the Meadow report on the limits to growth had been carefully read and commented, started to develop prototypes of what would later be called the passive house. The idea was simple. Rather than improving the efficiency of heating, we should avoid needing it in the first place by avoiding heat to leave the interior space. This meant a series of incremental changes to building components, a heat exchanger ventilation system, but first and foremost, a high-performance envelope that is both highly insulated and airtight. Parallel to the experiments of the passive house, industrials from the construction industry understood the need for efficient envelopes, and this led to both normative and technical innovation. In France, in 1988, the concept of human needs regarding inner climate was replaced by the concept of building performance. So this shows a change of paradigm from environment as comfort oriented towards the need of the users to the environment as an economy of resource. To make this transition possible, a series of technical objects were introduced into the building repertoire. So here we see something that we all know today, and we have learned to feel very negatively about it, which is the PU foam that has been largely used to address airtightness problems within the building. So, which was discovered in 1952 by Otto Bayer. But also, you see, starting in the 90s, a lot of commercial also showing that the whole building industry is starting to look, and the discourse is moving towards the idea of the building not only as a machine, but also as a living body. So with the idea of the skin, so with processes of things going in and going out. And also the idea of airtightness that you see in the second advertising from Troel. So this idea that, of course, you should keep air tightly within, and you should absolutely not let the inner climate communicate with the outer climate. Here again, this is an extract from articles within the professional press, looking very precisely on where windows have leakage and how to address those leakage problems. So of course, what I'm interested in is not actually the research and the inventions, but the consequences that it had on an architecture and on a conceptual level. And at the same period, you can see that architects are taking these new contingencies of technical contingencies and addressing it. And Professor Hans Koolhof had a chair in ETH and in EPFL, where he used the idea of the window to explore with his students what new tectonics had to be discovered to address those new technical requirements. So the idea behind that is that once you insulate, and here I'm coming back to the etymology of insulation, which comes from insula. My Latin is not very good anymore, which is to make an island. So to isolate what is within and what is without. I would like to discuss what are the spatial and conceptual consequences of this shift toward a very strict dichotomy between interior and exterior space. The work of Swiss architects like Guigon and Guyet, or Burkhalter and Soumi, or even Diener and Diener can be seen as a response to the technological requirements of a building like a living body, rather than like a machine. In that self, it distances itself from previous concept like the modernist blur of the threshold between inside and outside, or the postmodernist idea of the facade as a pure semiotic device. The invention of new tectonics of the envelope is the most striking and recognizable consequence of this new paradigm, but one could also state that the space defined by this envelope is also deeply linked to this issue. So of course here, this is a very modern a conception of space where inner and outer space, where the whole building is designed to enable a great relationship between inside and outside. And of course, all the details are geared toward this objective. And you can see in how the whole need to create envelopes and very tight envelopes had pushed architects in a very productive way to invent new aesthetics of the envelope and of the limits between inside and outside, and how to conceptualize the space. But what I'm also thinking, and maybe that I like to discuss, is that the fascination for precisely defined inner plans made of series of room in opposition to a fluid modern space can be seen as a way to produce a synthesis between space and the forces that supports it. So here I've put together two examples. On the one hand, you have a patent for a retracting ceiling arrangement. So when you push the door, there's a seal coming down that you never see that is going to seal that. So this is a Swiss invention that you find in almost every door now. Le Seuil Planète, for those who know. So this is all meant geared towards isolating the inside from the outside. And on the other hand, you have a very strict plans with a fascination toward rooms and very defined space. And what I'm looking at is the relationship between those technical systems and the spaces they create. And of course, in a larger space, what I'm interested in is to see how architecture as we think of it today, ecological architecture as we think of it today, has been an ongoing process for decades. And I think that understanding this recent history and its implication on the theoretical framework that we use can help us to address more precisely the great challenges architecture is facing today. Thank you all for listening.
Thanks. I got this microphone put in my hand, so I'll start talking. No, it's all good. It's all good.
Please.
No, it's a super interesting topic. Really, really fascinating. There's, as you've shown, there's been a lot of change in history on the perception of indoors versus outdoors. Should this be completely separated or not? And there's constantly this contradiction between the two. I think there's so many layers of research that you could go into. There's this complete technical aspect of it. There's lots of contemporary research on comfort methods of optimizing energetics, airflow, etc. So there's really a lot to do. I guess I would like to hear more about the notion of comfort, the experience of the user, the inhabitant, within these buildings, and how that plays into the way that you look at the research, because obviously you can't cover everything that's out there, and you've chosen a specific way of addressing this. So, but this idea that, you said something super interesting, with the passive house, that it moved from the needs of the human to performance of the building, and I mean, I'm wondering if at this point this is still the case, or whether we're shifting back at looking a lot more carefully at comfort, but also at what comfort means, how that is a very subjective and personal perception, and how that plays into your research.
Yeah, I guess I'm looking really at the 90s, so where this what is at stake today is not exactly the same debate, but I think you're absolutely right when you say that this idea of comfort has evolved. When you read the text about the first passive house, really what they are stating is we can keep the same comfort and use less energy. So there's really this idea that we don't have to change anything in our lives. So it's a very technocentric, the idea that with technology, with good insulation, with good airtightness, we can keep exactly the same kind of light level and never address the problem of scarcity of resource with another solution and just changing the technology. And I think today, and at the same time, you can see, so this is a very technologically driven approach. And at the same time, people like Auffret-Postel in France are already tackling the idea that we should also question comfort. So, for example, you could see that they are using the air blade that architects put into their wall and dilating it to the extent that you can inhabit it. And they are saying, okay, living in a space that is not cold but not hot can be very nice, and we don't have kind of ways to name that, but it can actually be very good. And the Maison La Tête is a great example of that. So of course they're already tackling the idea that once we accept to kind of I guess they opened the door that we are much more exploring today, which is, okay, do we need to live whole year round in exactly the same comfort at the same temperature and never change anything and always be super optimal, or can we have a jumper in winter, and can we live in smaller space in winters and larger in, so all this that has entered the debate was not debated at that time. At that time, the idea was how can we live with a very leveraged, and I guess the architecture of the Swiss box, as we know, is this kind of very cleared and defined and very airtight buildings are really a response to this idea that we should maintain a perfect level of comfort. And it's fascinating architecture, but it's really also relevant in that context.
Yeah. The other notion that comes to mind as you present your work is that of control as well, which I would expect also play a pretty big factor in it. Where if once you end up working with completely airtight systems where there is no opening, closing, etc., the question of who controls what happens within those buildings in terms of everything, airflow, heat, etc., I think changes a lot, right?
Yeah, of course. Well, today, again, I guess a lot of people are challenging this idea of super technicized building, and we now have real data also about the true efficiency of those buildings, which is not that good actually, because you need more ducts, you need more pipes, you need more motors, you need more, and then people misuse it. So the actual gain that you have is not what has been calculated, because people don't live the way as computers, so they do not close their windows or they do not open it enough. And so there's a great example in that has shown that it's actually not that big. But of course, there's a lot of going on in the idea of control, and of course, the architecture from that time is also very linked to the idea of, I mean, spatially to the idea of control.
Thanks.
Yeah, so thanks again for the presentation. Maybe a quick follow-up. So you were talking mostly about climate, right? So temperature and let's say humidity. Other aspects related to having an architect building. I'm thinking about the quality, right? Or let's say during the COVID, everyone's telling you open the windows to let exchange of air. So are there other aspects not directly related to temperature that should be accounted for, and what are the pros and cons, right?
Yeah, well, of course, I think this has all come in mind more recently because we have been dealing with this kind of very airtight architecture for 20 years, and now everybody is kind of understanding all the implications, I mean, cultural implications that it have, and we all had, I mean, if you live in Switzerland, you've heard about those buildings where you're not allowed to open the window, and people are all screaming about that. And this comes from, but this hasn't arose from nowhere, and there has been a very long process to come to this. And of course, what we are seeing today is a result, and that's what I'm kind of interested in, is how this whole, how this came to be, and how those kind of also now counterintuitive systems have been widely developed, but also how architecture has adapted culturally to those requirements. And of course, we almost are sure today that tomorrow we won't be building in that way. I guess we won't be doing kind of full airtight because we know that we have that qualities cannot be accounted to such kind of restrictive level as pure heat temperature and maybe moisture quality, and that actually people, the way they live is much more rich and complex than that. And of course, but then we have to surpass all the kind of ideas and frameworks that were put in place in that time frame of the 90s, because we are still using them daily as practitioners.
Thank you. That's a fascinating topic. Yeah, so my first question is how you position your work, maybe in the literature on the envelope. I'm thinking the politics of the envelope and how you follow. So the recent work of Sarah Pollard and Jeffrey Anderson, this kind of huge literature on the envelope, and to elaborate a lot later how this specific research will make new contributions to this body of work on the envelope. That's the first question. And then the second one, you said something very interesting. You are not interested, you said you're not interested in the inventions, which are fascinating, by the way, and the way you explain them actually shows that you're interested. But you're interested in the impact. Yeah. So you said you're not interested in the innovations, but in the impact that that this kind of technologies have on architecture. So how do you articulate? How do you articulate this impact? So what are the specific case studies, or is it just a cultural history of how it happened? And how do we not measure but evaluate this impact, and how we understand this impact? Is it just the kind of performance of the building? Is it the relationship between aesthetics and performance? Is this the ecology, the aesthetic, the performance, and the social aspects? So how far do we go in exploring this impact, and what kinds of impact are you interested in understanding, and how would you do it? I see a very interesting kind of cultural history there, but maybe you have other methods or other case studies at hand that you'll be exploring.
So to respond, yeah, of course I'm interested in the devices and the technological devices. It's just I believe my research will not provide new answers on those technologies. So this also answers the question about the envelope. I don't believe I will be making large contributions to how buildings works or to inventions. For that, I'm largely based on secondary sources and just kind of looking at how the evolution of techniques is digested. So how technical facts become cultural facts. And So for that, the impact and the way I methodologically, for now, what I'm looking at is looking at architectural details. So to a very precise level. So how a sill, how a window frame, how very small details in architecture by Swiss architects, maybe French and maybe Dutch, to have a kind of European context that is comparable. I'm not looking at the whole, and also climatically in the same range, and to see how the contingencies, so technical but also normative, because of course the 90s has seen the first rules and laws that informs that pushed towards performance requirements, and how these contingencies were either avoided, either used to create formal responses that were more than just technical responses. So if you see when I was showing maybe the white gold, this is purely a technical response, which is just a window that is that has a good performance, but it's made of plastic. It has very little cultural implications. But of course, a few years later, after all those inventions, people come up with great windows that have the same performance, but that have incorporated more than just the performance, but also all the ideas spatially and culturally that go with them. And so this is what I'm trying to see. So I'd like to access primary sources on building details, and also, because those architects are still alive, ask them if they were conscious of this, because we have text and we have debates going on at that time where we know that these issues were at stake. For example, the idea that the window was not something that was going to be designed anymore, just like before, because of course, before architects would design their windows, I mean, all the profiles and everything. And now it was becoming a very industrialized and highly technical system. So of course, there was this kind of idea that you were losing a kind of ability to design. So architects were discussing that at the time, and some were seeing that as a chance. And of course, they were building upon the idea of this context, and others were trying to hide it and to kind of retain this power of architecture. So I'm looking at this kind of struggle on how what I would call, I've called it before avant-garde architecture, which is not good, but not everyday architecture, but architecture that is architects that were very conscious that they were kind of addressing, that through their building, they were addressing large issues, how they were reacting to those contingencies.
If I could ask you, first, thank you very much for the presentation. I have one question that maybe I didn't understand very well in connection to what you mentioned about modernity, and if I understand well about more international style, maybe I didn't, because at least I'm very interested in your view, because the view that it seems that international style or modernity did was that this communication with anything that has to do with nature, like pilates, so you're not even, figure ground is not anymore a connection, framing the nature, not really creating windows towards, it's just the framing of nature, and using all these different materials from concrete to steel to glass that needs all this airtightness. So, but then I felt like you are saying that, for me, it's very interesting that modernity brings fluidity. You say spatial fluidity here, but you also mentioned about this connectivity to nature, as if it connects with.
Yeah, you're right.
I thought it was like all about airtightness in modernity. That's
yes. Well, actually, modernist buildings were not airtight at all. I mean,
because they couldn't, but
they couldn't. But conceptually, they would have liked maybe to be very airtight. But of course, if you look at plans by Nice or by Corbusier, there's always this idea of blurring the limit between inside and outside. And how do they blur this limit between inside and outside? Because they like to have this kind of spatial interplay, is by having very thin frames and very abstract limits, because of course they don't want to be kind of kept into this very historical idea of the facade that is both load bearing and the limit between inside and outside. They like to create loggias, they like to create a lot of different spaces in between. So in that sense, what I feel is that this idea of blurring the inside and outside in the 90s is a real challenge for architects, because if they want to keep producing this type of architecture, they have to kind of invent new ways to conceal much more heavy systems. So where you could put a 2 centimeter metal frame, you now need to put a 12 centimeter aluminium frame, and the weight, the pure weight of the glass has been multiplied by 5, so you have very heavy windows. So all these architects are kind of dealing with this. So they can either disguise it, and you have many examples of, well, you could say that the Seuil Planète, this one is a way to disguise those kinds of systems. You could think of very thin frames that are highly technical systems. And others kind of embrace those contingencies and say, okay, now we need to build with that. And this is actually our context. And let's kind of celebrate that. And we can have beautiful windows with heavy frames. And so that was about the inside and outside relationship. But you're also right that, of course, they're still very modernist in this idea of a fully controlled climate, and the idea that nature can be completely controlled. And in that way, the passive house is a very modernist idea. The idea that you will be fully heated, and something that is also very difficult to get out of, because I'm the first one to like to be in a heated place in winter. So it's actually quite difficult to get away from that.
Also, thank you very much for the presentation. I have one question. We're talking now about a lot about the inside of the box and outside of the box as this binary separation. But is there also considerations what happens inside of the box? Because not every room, you hinted at it a little bit with the inventions of Lacaton-Vassal and these spaces that are neither nor or both at the same time or vary over the year. Is there also inventions for within this Swiss box to differentiate rooms, to have different climates for, I don't know, different times of the year, different personal needs, different.
Well, that's something I still have to look at. I'm looking at, first I wanted, another part of the research that I haven't shown is the idea of, to explore the idea of thickness, and also because what is the difference between the void and what is conceptualized as void and what is conceptualized as full? Because of course, in traditional architecture, it's very simple. You have the wall, it's one material, inside everything is full, and then you have the space around it. But of course, in those kinds of building, the limit is much more blurred, because inside the wall, you have maybe 5 materials, you have air barriers, you have foam, you have load-bearing materials. So you're inside a very composite wall, so it's impossible to say. And a large part of the wall is actually concealing air. So what is considered as void is also found within the wall itself. And this is what Lacaton-Vassal are going to do. They're actually dilating the wall to inhabit it. You're inhabiting a part of the insulation. But for now, they're mostly the only ones to do that in my case studies. Of course, they're drawing upon a tradition of that, which are intermediate spaces of the. There was a great presentation by Thiago about that. But of course, this is so this has a long history, and they're kind of the tail of that. But in the 90s, most of the architects are mostly concerned about finding new aesthetics, and I think for now in my research, which are more about being able to produce a very sharp and very precise formal and spatial objects, rather than exploring various types of climates and threshold. I think this is something that today we are very concerned about. But from what I've seen in the 90s, this was not yet the idea. The idea at that point was, of course, kind of, they were just grasping the idea of this kind of necessity of airtightness and high insulation, and they hadn't yet processed all the problematics that came afterwards. And so, of course, the space resulted in this very kind of very strong dichotomy between inside and outside. And I guess what today we are kind of envisioning in many projects is the result of course, because these guys kind of did those things before, and then we had a kind of critical look on those buildings. I don't know if this is this response to it.
We have a last question, and then we have to move forward.
Thanks for the great presentation. While you were talking, I kept thinking about like how skyscrapers in New York changed with the advent of air conditioning, how they became sort of much wider because you could air condition these vast floor plans, office floor plans. I remember reading how if you look at the Empire State, that's a pre-air conditioning building, so they're more slender. You could open up windows and your office had to be close to a window because it's the stifling heat of New York summers. And so I was wondering how now that we are, I don't know, stepping back from trying to redefine our thresholds of comfort and trying to lower our consumption, how our architecture is changing, sort of going back to those, changing as an inform, right? The same way the technology led us to change it. So are we sort of embracing, new spatial concepts to facilitate that kind of thing?
Well, this is the tricky part, and the very interesting part is how material implications, so either air conditioning or insulation, is actually changing the big picture, which is the spatial, the plan, and the whole way we conceptualize the space. And I guess, of course, today there are many things going on in the field, and there are material changes that we see. I mean, from what, this is not the heart of my research, but of course, I guess my research was initiated by seeing those projects. But if you see buildings that come back to massive stone, because they have processed the problematics of composite walls. And so my research is also about saying, if to be able to do massive wall today, maybe we should understand why we have arrived here and why we have found problems in those composite and kind of buildings made of foam and made of those matters that are very difficult to kind of refresh and transform and everything. And of course, the idea of energetic consumption has also had a huge impact on, I don't know how you say in English, in French it's facteur de forme. So this idea that, I mean, that the bowl is the best shape ever because it has the largest volume within with the smallest surface outside. And so, of course, this has had a huge impact on spatial production of and of course, if you see in France, you have very deep plans and very thick buildings, because thick buildings are very good. So it has also been a huge lever for architecture, for design, to respond to technical contingencies, because somehow at some point you could have not a very performative insulation if you had a very good facteur de forme, and vice versa. You could have a Sana building that was super thin with a very bad facteur de forme. Still, I don't think this is, but you all will understand it. Because you had very, very powerful and very performative insulation. So of course, there's been a constant interplay between technicity and spatial implications that's been going on for 20 years, and people testing in and out. And of course, today we still, the issue isn't resolved. And also what I'm interested in is showing that it's an ongoing debate, and maybe a more complex one that we tend to see on the day we are living in, because we always tend to have a kind of a narrow picture.
Thank you very much for the presentation. I think we're going to move on to the last thing.